10 to the power 3. Y is equal to 113.205 times 10 to the power minus 3. And divide by your IZZ is equal to 65.694 times 10 to the power minus 6. So this will be equal to plus by 1.359 times 10 to the power 6 plus 200 divided by 104 times 375 times 5 power minus 3 divided by 2.859 power minus 6 is equal to 1.261 times 10 to the power 6 plus 200 divided by 104 times 17.936. 59.438. So this is equal to 62.058 megapascal. Is it megapascal? So in a term test, okay, we give 0.5 marks for this, 0.5 marks for this, 0.5 marks for this. Are we clear? Okay, you don't just write this and put this and then something go wrong down here. I cannot give you mark. Are we clear? Okay, be very precise. Okay, I know Dr. Cotton has been spreading rumor about this course. You get the wrong number, you die. That's not necessarily true. Are we clear? Okay. Question so far? Does this make sense? Yes, sir. Oh, X, you're right. Where are you? Where are you? 1 pint of beer. I make mistake. Okay. Then the next one, we are going to look at stress max, compression. And now compression is going to be at point where? Point K. Okay, at point K. So I'm going to again grab this image. All right. We'll grab this image. And then at point K, I think we call over here point K. Okay. So at point K, we know that the Z distance is equal to what? It's equal to 10 divided by 2, 5 millimeters, or 5 times 10 to the power minus 3 meters. The Y now is equal to what? 0.300 minus by what? 123.205. Okay, so this is equal to 300. It's equal to 176.795 millimeters or 176.795 times 10 to the power minus 3 meters. Okay. The approach here is different because point I and point K, the Y distance is not the same. Yes or no? When we were doing point A, point B, the values of the Y and Z are the same. Okay, so this one you have to be really, really what? Careful. So this one, we will calculate stress X. Okay, now we are going to calculate at point K. So this will be equal. So this is still positive. Right? So now at point K, right? We know that My will induce what? Compression. Okay. So minus, again, we have to put in 200 over 104. This still remains the same. Right? The 375 remains the same. The 2.859 times 10 to the power minus 6 still the same. So this is My. We have to look at the Z. So this happened to be still the what? The same. If you look at these two, right? This value, this form, and this form is still the same, but the only difference is what? Minus. The other difference will come to this, okay? So you still have minus over here, 200 over 104. 117.936 times 10 to the power 3 divided by 65.694 times 10 to the power minus 6. Now this value changes to what? This value changes to 176.795 times 10 to the power minus 3. Okay. So this will be equal to 1.359 times 10 to the power 6. And then you just put minus over here, 1.261 times 10 to the power 6. And then this will be minus 200 divided by 104 times 17.936 power 3 times 176.795 power minus 3 divided by 65.694 power minus 6 is equal to 92. Hey, wait. 200 divided by 104 times 17.936 power 3 times by 176.795 power of minus 3 divided by 65.694 power minus 6 is equal to 92.825 times 10 to the power 6. Okay, let me see 300 minus 123.205. 176.795 is good. 176.79. Okay. So this will be equal to 1.359 power of minus 6, 1.359 minus 1.261 minus my 2.825 is equal to minus 92.727 times 10 to the power 6 Pascal. Are we clear? Okay, it's not that difficult. It's the analysis. Once the analysis is right. Okay, I'm going to, let's say we do something more. Okay. Next, we are going to locate the position, not position, the location, or locate the location, Eugene, really, of the what? Okay. So I'm going to show you the true form of the formula. Okay. So we know the neutral axis will locate in the where? Will intersect the what? The steel. We are going to focus on the what? Steel only. Okay. Don't need to look at where. Don't need to look at brass. Okay. So stress X is equal to 1.359 times 10 to the power 6. Okay. Minus 200 over 104. We close bracket. And we have our my over Iyy multiplied by z. Sorry, the true form is this is positive and this is negative. Okay, so what I wrote down here, that you see this sign over here, this is known as the what? The true form. True form means it's from the formula book, which I will what? Provide. But on the transformation, you have to be aware that this is y and this is what? Z. Are we clear? Okay, that is why a lot of students ask me why, Eugene, this is plus and this is minus. If you look at moment about y, positive, y is always going what? Upwards. But if you look at z, usually on the horizontal axis, right, the z will go from where? Left to what? Right. For this what? Right to where? To left. For this reason, that is why it's going to be what? Minus. Are we clear? Okay. Now again, we look at this. Okay. So the first thing we like to do, right? So now we have to remember this is our transformation that I'm going to draw in blue. Okay, so this is our y. And this is our what? Our Z. Okay. So we are going to locate the neutral axis. Okay. The position on the neutral axis on this red line I'm drawing. Can you see this line over here? Right. Because the neutral axis will pass the steel, so it will go in either this direction or this direction. Yes or no? Right? We don't know where it is yet. Okay, so the neutral axis can either go this way or this way. So this is your neutral axis. Okay, we don't know where it will go yet. That's what we are. So now we want to focus on, I'm going to call it the web left-hand column or left-hand column of the web. We also can have right? So this is equal to 0. And this will be equal to 113.59 times 10 to the power 6. Okay. Now, if we look at our moment about y, okay, moment about y, for this case, right, it's going to be what? Negative. I repeat, it's going to be negative. So you over here, you still put positive 200 multiplied by 104. Now, moment about y is minus 375. Any idea why? We're applying the formula now, right? For moment about y to be positive, it has to be in which direction? That direction. Our actual load is in what? It's opposite in direction. Are we clear? This is where when you apply the formula, you have to be really, really what? Careful now. Okay. Then from here, our IY is equal to what? Our IY 2.859 times 10 to the power minus 6. Okay. So do we know our Z distance? Yes, we do know our Z distance. Our Z distance is what? Positive 5 times 10 to the power minus 3. Can someone tell me why positive? Because it's on the Z positive side. So for Z positive, this is over here. This is Z what? Negative. Where along Y is we don't know. Okay. So where along Y? Okay. Now let's look at the next one. If we look at our moment about Z, our moment about Z, for it to be positive, right, using the formula, moment about Z, this is your positive direction. But in our analysis is what? It's minus, okay? So this is 200 divided by 104 again. Now this become minus what? Minus our 17.936 times 10 to the power 3. And then divide by what? 65.694 times 10 to the power minus 6. Y position is what we don't know. Okay. Y over here, we know our Z because we know Z is fixed by what? Positive what? 5 times 10 to the power minus what? Yes or no? It's fixed. Okay. So from here, we calculate. So this will be equal to 1.359 times 10 to the power 6. This will end up negative. So 200 divided by 104 times by 375 times by 5 power minus 3 divided by 2.859 power minus 6. This is equal to 1.261. 1.261 times 10 to the power 6. And then the last one, negative will become positive. 200 times by 17.936 power 3 divided by 104 divided by 65.694 power minus 6 is equal to 525.045 times 10 to the power 6. Okay. So, and this you have your Y. So when you calculate your Y, so Y is equal to 1.359 minus 1.261. So it's minus 0.098 times 10 to the power 6 divide by what? 525.045 times 10 to the power 6. Okay. So this will be equal to 0.098 power of 6 divided by 525.045 power of 6. So it's equal to 186.65. That's not a good unit. 0.186 or 0.187 times 10 to the power 3 meters, or minus 0.186 millimeters. Okay. The minus means what? This is relative to where? Relative to the what? Centroid. Are we clear? Okay. I'll stop here. Later on, we will go again to find the right-hand column. Very straightforward formula. Thank you.